Hey guys, Artham this side और आज हम सॉल्व करने वाले हैं आज का LeetCode क्वेश्चन which is problem number 169 majority element. Right? So let's first read the question. In the question you're given an array nums of size n and you have to return the majority element. Now let's first understand what is majority element that is being asked. The majority element is the element that appears more than n by 2 times and floor of n by 2. Right? So there are first of all there are two things. One is seal and other one is flow. I'm sorry, other one is flow. And what does we mean by that? Let's first understand seal. For example, you have a division 3 by 2 and you have to take the seal of it, right? Take the seal of it. So actual answer would be 1.5, right? But you will have to take the next integer value which is greater than the answer and is an integer and is a whole integer, which means 2 would be answer in case of seal. But in case of flow, what would be the answer? Actual answer was 1.5, right? Actual answer was 1.5. But in case of flow, you'll take the lowest integer, just one lower integer from the actual answer, which means one would be your answer, right? One would be your answer in case of flow. So that's the difference between seal and flow. So that's what's being asked from us. We have to find the majority element, and the majority element is the element that appears more than n by 2 times and floor of n by 2, right? You have to take the floor of n by 2, right? So you'll just take n as integer and it will automatically give you what? Flow, right? Give you floor automatically. You don't have to use another different function for that, right? You just have to take n as integer and your answer will automatically come as flow of that division. You may assume that the majority element always exists. So it is a very important condition. I'll tell you why. So let's see the example and let's understand what majority element is exactly. So for this array the size is 3 and the majority element would be which comes greater than 3 by 2 times, like floor of greater than 3 by 2. So this division would give us 1, right, which is floor of this division, right? So our majority element in this particular array would be the element whose frequency is greater than what? 1 in this particular case. So let's count the frequency. So 3 comes 2 times and 2 comes 1 time. So our answer would be 3 as its frequency is 2, which is greater than n by 2, that is greater than 1. So 3 is our answer in this case. Let's quickly see the example number 2. In the example number 2, let's count the frequency. 2 comes 4 times and 1 comes 3 times. And the size of the array is what? 1, 2, 3, 4, 5, 6, 7. So we had to take 7 by 2, floor of 7 by 2, which would give us 3. So we have to check the element, majority element would be the element whose frequency is greater than 3, not equal to 3, greater than 3. So 1 cannot be the answer. 2, which has frequency 4, which is greater than 3, is the answer. So we'll return 2. That is the answer. That is our majority element. So how will you approach this question? A basic approach for all those who know little bit of STL and C++ would think of maps, right? Let's just count the frequencies and just find the element whose frequency is greater than floor of n by 2, right? So we'll use an unordered map. And we'll just count the frequency of every element by inserting it into the map. And we'll say after counting the frequency, we'll see elements whose frequency is greater than n by 2, and I have already told you don't have to take floor separately because n is an integer. It will automatically take the floor, right? It will automatically take the floor of this division, right? So you will just use an ordered map, right? So it's basic approach. Let's see the code and we'll talk about time complexity and especially space complexity for this question. So this is our code. This is our unordered map code where we are using an unordered map separately to count the frequency of every element, right? Let's take this example 3, 2, 3, right? 3, 2, 3, where n is 3. Size of the array is 3. So what you're doing, you're just iterating this array and you're inserting it into the map, which means when you have declared a map, automatically all the values become 0. This is the value and this is the key. All the values are initialized by 0, right? So when you do map of nums of I, nums of 0 would be first I is 0, so nums of 0 would be map of 3, right? Map of 3 plus would be, I said map is initialized with value 0, and we are increasing the values, we are increasing the value for the key equals to 3, right, by 1. So what will happen in the actual map? The key 3 would have a value 1, now would have a value 1, right, increase from 0 by 1, right. Value of I would increase, I would be 1, and map of this would become what? This would become what? Map of nums of 1, nums of 1 is 2. So map of 2 plus plus would be now 2, value would increase by 1. So initially value of 2 corresponding to 2 was 0, and I have increased the value, which means I have increased the frequency of 2, that I have found a particular 2 which I have to insert in my map, right. Then value of I would become 3, I'm sorry, 2. Then this would become what? This would become map of 2, right. In previous case it was map of 1. Now it no it in this case it would become map of 3, right. This is not the index. Nums of 2 is 3, then it would become map of 3 plus plus. Now I have a 3 already in my map. So what will it do? What will this plus plus do? This will automatically increase the value which I have for 3, which is already stored in my map, by 1, right. So this 1 would increase to 2, right, which means, and I have iterated all the elements, right. So this final map would give us frequency of every element, every distinct element in this nums array, right. So I have got the frequency in the map, and I'll just take the element from the map whomsoever frequency is greater than n by 2. So I have just iterated the map, and this can be accessed through dot second, and this can be accessed through dot first, and this can be accessed to dot second, right. So I have just taken that whosoever, right, this represents frequency, right, this represents frequency, and this represent distinct elements. So whosoever frequency is greater than nums of size by 2, return that element. An element can be accessed by first, I have already told you. So return that element at once, and if not found, return -1, right. So this is our brute force. This is a brute force approach. Sadly, in this question, brute force approach in this question, let's see how much time complexity and space complexity this approach is using. So for iterating this whole array which is of size n, we would take O of n complexity, right. We're iterating every element once in that array, at least one in this sums array. And for iterating map, let's say in worst case, this iteration would be directly proportional to the number of distinct elements, right. Number of distinct elements. Why number of distinct element? Because map only stores keys, right, keys and corresponding values just get increased, right, just get increased. So map only stores keys first and corresponding value, right. So map size depend upon the number of keys. And what are keys in a map? The keys are nothing but total number of distinct elements, right, total number of distinct elements. So the time complexity for this loop would be directly proportional to the size of the map, which is further directly proportional to the number of keys, which is nothing but number of distinct elements. Let's say in worst case your array nums had all the elements distinct, which means all n elements are distinct, which I can say that in that case the size of the map would be n. Size of the map would be n, and our time complexity for this loop would become big O of n in worst case. So I can say big O of n for this loop and big O of n for this loop would be nothing but big O of 2n, or I can say that it's just ignoring this constant, it's just big O of n. So this is our time complexity, and let's look at the space complexity of this approach. We are just using extra space for this map, and I have already told you its the size of the map that is directly proportional to the number of keys, which is further directly proportional to the number of distinct elements. And in worst case it can be n. So space complexity for this approach would be big O of n. Now this is a basic approach, right. This is a basic approach. We're using O of n time complexity and O of n space complexity. Now can we further optimize it? Or the interviewer can ask you, can you do this question without using a map or without using STL? Can you do it without using map? So our answer should be yes, we can. And we can also further optimize this space to big O of 1. And how? Let's see how. In the second approach, we're not going to use any map. So we can also say that we are solving this question without using STL, or further optimizing constant space, right. So this approach is known as Moorey's voting algorithm. And how does it work? Let me just explain this. Now this approach doesn't use a map to count the frequency. What it does in that case, what it does rather, it just now understand this. What is the basic property of a majority element? It should come greater than n by 2 times, which means it should come more than half times, right? More than half times. Let's say the size of this array is 7, so it should come at least 4 times. At least 4 times, then only your majority element would exist, right? So let's see how this approach would work. What we'll do in this approach, let me just clear it. What we'll do in this approach, we'll just take the count. As 0. And understand, we'll consider that the first element is a majority element, right? That the first element is a majority element. And if I find another next element same as this previous element, which is our majority element, which we have considered, it is not given in the question, we have considered it. So let's say if the next element becomes same, we say increase the counter, right? Increase the counter. And by increasing the counter, you mean whenever I get this element equal to the majority element, I can say that I will increase the counter. And I will keep on increasing. How many times I would increase the counter for a majority element if it exists. Like if it exists, I would increase it at least 4 times, right? At least 4 times. Because it should majority element's frequency should be greater than n by 2, which means in this case should be greater than 7 by 2, which means should be greater than 3, which means it should at least come 4 times, which means I should increase the counter at least 4 times. At least 4 times. And for all those elements which are not majority element, I'll decrease the counter. What I'll say, I'll decrease the counter. Now understand this. I'm increasing the counter for majority element. I'm decreasing the counter for non-majority element. So what would be my final counter value? What would be my final counter value? Right? It would always be greater than 0. I can see that it would always be greater than 0. Let's understand. Let's say 2, 3, 4, 2, right? And the size of this array is 5, right? And 5 by 2 would be what? 2 would be 2. So our majority element would be the one which has frequency 3, which is greater than 2, like at least 3. And let's say I have considered this as majority element. First element is a majority element. And you know that in this case you see that 2 comes 3 times, so 2 is a majority element. For this case, output would be 2. Now let's understand this. Whenever I am encountering a majority element which is 2, right, I would increase 1, right? Let's say increasing 1, I'm representing it by plus. And for non-majority element, I would decrease. Let's say I would decrease all those non-majority element. Let's first increase value for all majority elements and decrease value for all non-majority elements. So count the number of plus, 1, 2, 3. Count the number of minus, right? 2. So initially count was 2 before iterating this array. Now count has increased 3 times, which means count value would be 3, and decreased 2 times, which means count new value would be decreased 2 times, which would give us final count as 1. And in all the cases, whenever there is a majority element that exists in this array, the count values always would be greater than 0, right? Even if it becomes 0, let's say there was 1, right? And even if it becomes 0, we would say that there is no majority element, because majority element should come more number of times than the other element. And if it is coming more number of times, then the final count value would be greater than 0, because it would get increased more number of time rather than getting decreased, right? It would be increased more number of times rather than getting decreased. Let's say, for in this case, it is getting increased 3 times and getting decreased 2 times. So it is getting increased more number of times rather than getting decreased. So this is our logic behind what? Moorey's voting algorithm. So how will we code it up? I have already told in this approach what we say. We do not have initially we do not have a majority element. I've just used that 2 example just to explain you, right? So how would we approach this? We'll say I don't know what is the majority element. Let's just take the first element as majority element, right? Let's just take the first element as majority element, and initially the counter was 0. When I declare the first element as majority element, I would say that the counter should become what? The counter should become 1, right? The counter should become what? 1, right? Counter should increase. When I encounter this element, when I encounter this next element, if the next element is my equal to, let's say the next element is a of I, if it is equal to majority element, I would say I have to increase the counter. Like I have to keep a count of the frequency, right? The frequency of every element. I would say increase the counter. And else if what? Else if what? If it is not equal, if it is a non-majority element, I would say that obviously what would happen? That majority element would not be equal to that this element, right? This element. So I would say just decrease the counter. Just decrease the counter. What to do? Just decrease the counter. Just keep on decreasing the counter. Because because what will I do for non-majority element? I would say just decrease the counter. And whenever your count becomes 0, whenever your count becomes 0, just initialize whatever element you are on as the majority element, and again set the count as 1. This is our approach. This is a basic approach, right? This is a basic approach. Now this is the approach. And we'll find the majority element using it. We can directly return this element as the answer. Or what we can do, we can check the element. We can also use a further for loop to check the frequency of this majority element, whether this is actually our majority element or not. This further step is called verification step, right? If it does not exist, in case it does not exist, but as in the question it is mentioned that it always exists. So we do not have to run a verification loop. I've just run it just to show you that it needs to be done if it's not mentioned that it is always present, majority element is always present, right? Then you have to verify whether the element you had found is a majority element or not. Now let's see the code quickly and go through the time complexity. Here we are not using any unordered map, which means we are not using any extra space. So our space complexity would be what? Big of 1, right? This is our approach. I have already explained it. If majority element is equal to what? First element, I have first initially declared the first element as the majority element, right here. And if the element initially the counter is 0, if the element I am iterating num, which means I am on this 2 again. If the majority element is equal to 2, increase the counter, which means the counter would become what? Counter would become 1. Initially it was 0, counter would become 1, and it would go to this 2, next this 2, right? Then again this for loop would run, and this condition would again be satisfied because majority element is still 2. Majority element is still 2, right? Let's say majority element is still 2, and as it is equal to 2, the counter would increase again, which means counter would become 2, right? Counter would become 2. Then I would say I have found an element. Next element is not my majority element. So I would say that come in the else case and decrease the counter. I have decreased the counter. Again for this one, it is not equal to the majority element, which is 2. Then I would decrease the counter further in this else, right? Again from this one, this would become 0. Our counter would become 0. And for this one, I would say if your counter has become 0, then consider this element, whatever element you are on, as the majority element. So I would say majority element, get yourself updated with value 1, right? And set the count as 1, that I have found a majority element, right? Then what will happen? Again majority element would be checked with this 1, which is now majority element, would be checked with this 2 when the for loop iterates to the next element, and this would again be not equal. And if it is not equal, I would say just decrease the counter again when it will come on this 2. I would say just when your counter is 0, just update the majority element, which would be 2 now in this case, which would be 2. So just update your majority element from 1 and increase the counter to 1, and in further iteration it would come out of the loop. So I would say in final value, my count value is 1, right? My count value is 1, and if it is 1, which means I have found a majority element, and I would say just return whatever the element I have found as the majority, and in this case the answer is 2, and you can also verify it from here. The answer is 2. And I have this use for verification. This use This is used for verification whether the element I have found, which is 2, has the frequency greater than what, n by 2, then only return it, if it is true, if this condition, whole condition is true, then return this majority element. Otherwise, say that I haven't found a majority element or the majority element does not exist in this array, return -1 this case. But you don't have to do it for this particular question, but because it is mentioned that the majority element would always exist in this question. So our time complexity would again be big of n for iterating this array just once, and for verification if you're doing, it would become 2n, but it would eventually come down to n. So our time complexity for this approach is again big of n, but a space complexity is optimized. We are not using any unnecessarily unordered map. We're just using what, variables with constant space. So our time complexity would be big of 1. So this is the optimized time complexity, which is achieved using Moorey's voting algorithm. That's all for today. And do try this question. If you do try this question by using brute force also, which is of time complexity n square, and you have to find out what that is. And do see this video. If you have any doubt, just drop down a comment. I'll reply as soon as possible. I'll paste the link of this problem in this description again. And you know what you have to do. You have to write solved in the comment section, so that I know that you have solved this question and you have understood this properly, right? So that's all for today. Coding karte rahiye. All the very best.